Today we're going to talk about a bit of a finicky calculation we have to do, but a very, very important one, and that's determining what the limiting reagent in a reaction is. The reason we want to do this is so we can determine how much chemical is required for a reaction to take place. So in our lovely math world, where we get to pick, okay, this much chemical is reacting with this much chemical, we can set up scenarios where you have exactly a perfect amount of chemical reacting. But that can only happen in our theoretical math brain. In practicality of doing chemical reactions in a lab, that's never going to happen. You're always going to have a bit more of one chemical than the other, and even getting it within a couple grams of each other is pretty unusual. So that means we always have one chemical that's the limiting reagent and one chemical that's the excess reagent. The limiting reagent is whatever chemical gets completely consumed by the chemical reaction. And both of these are always reactants. They are never products, which is why we say they're reagents. So the limiting reagent is the chemical that gets completely consumed by the chemical reaction. Once all of that chemical is gone, the reaction stops because you need it for the reaction to take place. If there's no more of it, there's no more reaction. The excess reagent is then whatever chemical is left behind. It's excess. There's more than enough of it. There's a surplus. There's greater than required. So there's always going to be a bit of excess reagent that gets left behind. If we want to figure out what the limiting reagent for a reaction is, we need to know how much of both reagents are present. Sometimes you will see, and you have seen this already, a chemical say 10 grams of this chemical reacts with an excess of another chemical. You don't need to do a limiting reagent equation for those ones because it's telling you that the one with the number of grams is the limiting reagent, and the one that's excess is, well, excess. There's more than enough of it. How much? Enough. It's not saying exactly how much because it's not important to the question. But in a lab, you're not going to have that scenario. You're going to have 10 grams of this thing and 20 grams of that thing, and you need to be able to figure out which one's the limiting reagent. And hey, sometimes it's the one that's 20 grams, not the one that's 10. Depends on the chemicals that are involved and the reaction that's involved. So the way we figure this out is we take both of our known informations about our two reactants and we pick one product for the reaction. Does not matter which product it is, just as long as you use the same one for both chemicals. And then you do the calculations twice, once for each reagent that you're given information about. Hypothetically, you could do it more than twice if you have more than two reactants, but most of the time it's just twice. So you do the calculation twice, once for each reactant, and then whichever chemical is going to produce less product is your limiting reagent. Because that means that less of your product is able to be created with that chemical, which means once you hit that point, the reaction is going to stop because that chemical's been completely used up. There are some other ways to do it, but this is the way that I prefer because it keeps things simple. Always calculate the same chemical for both of them. Sometimes people will stop at doing moles and figure out the mole ratio for them. I actually find doing the one extra step of going all the way to grams makes it a bit easier conceptually because then we're doing the exact same reaction as our regular stoichiometry, the exact same type of calculations. So it's a bit easier for people to just run on autopilot and go all the way to the end and to make sure that you get numbers that you can compare correctly. You can also sometimes have to determine how much excess reagent you need. Well, in this reaction, you know which chemical is the limiting reagent, and you're told how much limiting reagent there is. If you want to know how much excess you need, all you have to do is just calculate from the limiting reagent how much of the other reagent would be created. But we're not going to just say, oh, add this much reagent, because sometimes we're human, we make mistakes, and sometimes there can be impurities in reactions as well. So we will add an extra 10% on that number that we've calculated, and that should give us enough reagent, or excess reagent, to ensure the reaction completely takes place.